Hello. Good morning to everyone. So it is audible to you. Just giving confirmation.
Yes,
Okay, fine. So everything is fine. Okay, good. So we already told you. So you enter your name, username, your name, space, or roll number. So many times I will tell you, but still some of members entered the wrong way. So better to change your name, username. Okay. So today our first section. So introduction to Embrace system. So it is visible to you. Say yes or no.
sir.
So introduction to Embrace system. So first question. So what is Embrace system? Based on your knowledge. So what is the Embrace system? Any idea about it? Embrace systems? Anyone, guys? Please respond. So combination of software. Most of members know the simple definition. So combination of software and hardware, right? Yes or no? So what is the software? What is the hardware? So we're talking about the Embrace system. So it is a combination of two things. So combination of hardware and the software. So we also given the some definition to the Embrace system. So two different type of definitions, both are same. So based on your interest, you choose any one of the definition. Okay. So I mean the definition is an Embrace system is a combination. So same answer. Say it is a combination hardware and software. So designed for a specific function or task. So you need to design a single task. So using a user software and hardware. Design a single task. Is it clear, guys? So it is a combination of both the computer hardware and software. Computer hardware means it is a possible element. Okay. And next one is software, designed for the specific function. I guess. So it is specialized computer operating system. Is developed for specific application purpose. So it is a part of a law system also. The embedded system is a system or a part of large system. Are you clear, guys? Is a part of large system or it is an individual system. Is called embedded system. Is it clear or not? So today you are using a lot of embedded systems in your real time environment. Without embedded system, you can't do the any one work. Yes or no? So you are using a lot of embedded systems in your real time or real life for nowadays. So it is a definition of the memory system. And next, applications of embedded systems, where it is used. So many of applications is there. We're dividing some categories. So first one is consumer electronics. So we are using consumer electronics. Where it is used? Consumer. So what is the consumer electronics? Guys, anyone? So what are the consumer electronics? Household equipment. Household. It is real or not? Household equipment is called consumer electronics. Yeah, right. Washing machines, TVs, micro ovens, digital cameras or CC cameras. So these are the consumer electronics, right? Nowadays, these are very common in the household, any one of the machine. So these are the consumer electronics, right? Yes or no? Guys, first give the preference to your regular work. Okay. Then after give the preference to this. Okay. Yeah, fine. And next one is automotive systems. So second one is the automotive system. Nowadays, most of cars are using automotive something equipment. So automotive systems. So modern vehicles is related to the embedded systems. So suppose ECUs. ECUs means electronic engine controlling. ECU. So most of the future cars we have a ECUs, different ECUs. And next ABS. I think most of members know the ABS. So it is available in bikes also. So ABS means, what is the ABS mean? Full form of ABS? Anyone? So what is the meaning of ABS? Anti-lock braking systems. And next one is the airbags. Next second automotive example is airbags to control the. And next infotainment. So we display some information related to the car or some entertainment information on the car dashboard. Yes or no? That is the infotainment, right? And the navigation system to travel the long distance you with the help of maps, Google Maps. The navigation system. So these are the automotive applications. And same way, next one is the industrial automation. So you're using most members some automotive works like using PLCs, so programmable logic controllers. So that is also an embedded system. Robotics and assembly lines. Yeah, right. Supervisor control, data equipment, SCADAs. I think if these are related to the EEE department, you understand the EEE students only. So first one is the PLCs and robotic assembly lines and the supervised controlling equipment. So these are the industrial electronics. Next, medical devices. So nowadays, most of us know that to measure the body related information, right? Yes or no? Most of us know. So those are the PISO markers. Yeah, ECC is right. Good. And some of members have developed some projects also, patient related. So patient monitoring systems and MRI and CT scanners and infusion pumps. So these are the medical equipment, right? So in medical equipment, we are using embedded systems. And same way, telecommunication. So one of the most popular communication network is telecommunication, right? So in this also we are using embedded systems like mobile phones. So I think I have a doubt, guys. Mobile phone is the embedded system or not? So you are regularly using the mobile system, right? So most of members, all members who are joined your live section, all are using mobile phone, right? So mobile phone is the embedded system or not? Just give me confirmation. Embedded system or not? Yeah, we given that some differentiation. So how to differentiate the embedded system and non-embedded systems, right? Good. So mobile system also, embedded system, good. And routers and switches. Where it is used for routers? Internet purpose, right? Routers, switches. So yes or no? And same way, satellite communication systems. So here is the satellite mobiles, right? So these are also embedded systems come. And same way, next one is home automations. So nowadays, most of members using the most household equipment like thermometers, smart thermometer to collect the house information, to collect the house inside the temperature of house. A security system to secure your home, like CC cameras or some sensor-based systems, and a light controlling system. So olden days, we are controlling the any equipment in home. We are using switches, right? We are using switches. Nowadays, we are using directly mobile phone to operate the internal application, home applications, right? So yes or no? Yes or no, guys? Yeah, right. And this is how home automation related embedded system equipment. Next, aerospace and defense system. So we are using, some of members knows the some aerospace related equipment like flight control systems to control the flight, right? You are using the embedded system equipment, navigation systems. So we are also using navigation in the space and the missile guidance and the radar systems. So most of us know the landing and takeoff time. You are using the some radars to set the proper runway. So in that equipment also embedded systems. And next one is the banking and retail retail space, right? So last one is the banking and retail. So so we are using ATM machines, right? All our banking account, right? So we are using regularly. Some of days to draw the amount from the ATM machines, right? So it is also embedded system. Is it clear? It is also an embedded system to go. It is related to the your money, your bank account related information, right? So all ATM machine is not a all ATM machine is called of just machine. It is doing multiple tasks, but is a little bit of a part of embedded systems inside the ATM machines, like barcode readers, money counting machines, printing machines, displays. These are the embedded equipments, right? So that's why item machine is also embedded system. And next one, POS systems, point of sales machines, and the like so DMart systems, billing machines, and the scanners. These are also POS machines and barcode scanners. So to scan the identify the items using barcodes. Is it clear, guys? Yeah, okay, sure. So these are the different applications of embedded system, right, guys? So nowadays, so most of members know that this basic some embedded equipment, right, guys? So the next one is the what is the block diagram of embedded system? What are the components? What are the blocks inside the embedded system, whole embedded system? So for suppose you design any embedded system, you know the basic blocks. What are the required things? So that's why given that this block diagram. So observe here. So every system is mustn't depend on the environment. So you require things. Suppose you need to design your home thermometer. Suppose you know the home temperature to track the your home temperature. So you must know that temperature depends on the atmospheres also. So outside the home and inside the home, what are the temperature inside and outside? So we give them just that is the example. So observe here, so many blocks, sensor blocks, controller software, clocks, operator, actuators, and displays. So you observe here, one of the most important block in a digital electronics. One of the most important block that is clock. So how to, so guys, listen carefully. So how to generate the clock? How to generate the clock? So that is the important thing in a digital electronics, right? How to generate the clock? Crystal oscillator, right? Only crystal, right? So what is the oscillator output? What is the output of oscillator? So the oscillator output is what is the output? Sine or sway? Right, sine. But you can require clock signal. So digital clock signal is a two states only. But in crystal oscillator output many sides, right? So that is the sine wave, analog signal, right? But is a clock is required digital signal. Only two states is there, either high or low. So how to convert the oscillator output into clock? How to convert the oscillator output into clock signal? Anyone? So most of us now understand that one. So the oscillator output is sinusoid signal, right? But required clock signal is square wave. Yes or no? Just give me confirmation first of all. Clock signal is a square wave, right? Yeah, yeah. So but oscillator output is sinusoid. Sines. Yeah, right, right. So some members are given the answers ADCs and rectifier circuit. So rectifier there is to convert the sinusoid to some rectification and means AC to DC, pulsate to DC, convert the rectifier circuit. So here AC to DC. So in ACT, the DC circuits also clock signal, right? Yes or no? In ADDC circuit or ADC systems. So you convert the analog signal into digital signal, you required clock also, right? So in previous sections, you already don't know clipper and clamper circuits, right? And it is experiments on the basic electronics lab. So unwanted portion is cut by using clipper circuit to generate the clock. Yes or no? So so you already observed or have seen some pictures in class circuit. So two capacitors are connected to the parallel. Yes or no? You just using just simply oscillator is not sufficient to do generate the clock. So some external circuits is there. So capacitors are connected to the parallelly and generate the clock, right? So remember this point. Every digital system required clock, but that clock is generated using the which component? Crystal oscillator. But crystal oscillator output is sinusoid signal. So sinusoid signal is converted to square wave. You are using clipper circuit. So to convert the sinusoid to square wave, you must use the clipper circuit. So clipper circuit, what is the output of a clipper circuit? Is cut the unwanted portion of signal simply, right? And next one is a control software. So observe the second one is the software requirement to give the some instructions how to control, so how to collect the information when you receive the information. So next, this is how to do the decision to control the output component. So everything is given some instructions, right? So how to give the instruction to the microcontroller? How to give the instruction to the microcontroller? Anyone, guys? So how to give the instructions to the microcontroller? So through instructions, right? To give the some instructions to the microcontroller, based on that, we control the some input to output, right? So that is instructions, right? Good. And next, to collect the information from external environment. How to collect the external environment? For suppose, give an example to the washing machine. So how to give the instruction to the washing machine? Guys, so how to give the instruction to the washing machine? It is a machine, right? You directly not communicate with me or with you, right? Yes or no? You directly not communicated with to you. It is possible or not? Yes or no? So how to communicate to the washing machine? It is simply a sensor or user inputs, right? So no. So here is a two different type of input components is there. So first one is buttons and second one is the sensors. So manual interface, manual involvement is there. You must use the push buttons or potentiometers. So these two ways to the give the user input directly to the machine. So any other way is there? Anyone? Any other way is there? So suppose you give some instruction to the your washing machine, you select the internal operations by push buttons, right? You select the screen on the screen, you select the particular operation, right? So to adjust the speed, we also using the push buttons. So most of a different more operations is there. You must select to do the at least potentiometer. If this is two ways to the these are two ways only. Give it a mobile phone also okay good. Mobile through mobile phone. What type of interface is there? You must open the mobile app and you set them some buttons on the mobile app. You directly given the information to the app of buttons also, right? Yeah, software is there, right? And we give the some instructions to the machine. You must use the two ways. First one is push buttons, and the second way is the potentiometers. Okay, and some automation is there. You must use the some you prepare some system to automate you operate the automatically. You must use the sensor without your involvement. Without human involvement, you must use sensor to collect the automation to create the automation in your system. So first block is input blocks, so that is the sensors, and next one is control software. Third one, you must use the behind the block diagram clock, and the next one is displays. So sometimes using different type of displays is there in real time, right? So we regularly use observe the some type of displays. So to display the numbers or characters, right? So these type of displays, right? So these are the display some information. So you need to design the system. Assumption, design the system. So it automatically collect the information and automatically control the output component, output things, right? But you don't know, understand. So what happens inside the system? Suppose you use a design of sensor based system, the sensor is collected some information. Based on the information, it automatically control the output component. We design them basically, right? But what happens? Sometimes is sometimes it have a wrong information, and same way is control the output component. So these type of situations, so how to identify the is the wrong situation and wrong data. It is collecting the wrong information, right? So those things avoid. You must use the displays to display that these are the information right now. You display the system. So it is right data or wrong data. So you must identify the the data. So that's why they're using the displays. And next one is the activators. Activators means it is output component. So when you give the a signal to the component, so then activate the some internal function. That those type of components is called activators. Is it clear, guys? Activator, what is the activators means? So require some input signal to activate the internal operations. Like so, you give the info some in old days to the LED. It is LED is the output component, right? It is an activator. So it requires some signal to activate to glow the LED. So those type of components are called activators. Is it clear, guys? So these are the embedded system block diagram. Any doubt related to this block diagram, guys? Any doubt? So there is a feedback network, okay? In the embedded system, there is a feedback network. In the complicated systems, to check the components work or not, like um, so what are the blocks in the embedded system? So this is a conclusion. This slide's conclusion is just related to the block. What are the blocks inside the embedded system? So actuator means it is an output component. Just it is an output component. So it requires some input signal to actuate the particular components, the output component. So that's why it's called the actuator. So example, LED, relays, bulbs, displays. So these are the actuators, right? Okay, thank you. Any doubt related to this slide? Yeah, okay, fine. So embedded system structure. So suppose you design the system, embedded system. So how to design? So you need some guidelines to design the system. So that is a structure design, right? So first one is sensors. So sensors means just input component. You think it is a input one. So sensors are for automation purpose, so for a manual purpose using push buttons, right? So first one is the sensors. So sensor means input component. And next one is, so your required is there. Suppose you are using two different type of components, analog and digital. So all microcontrollers are digital systems, right? So you require digital inputs only. You understand digital inputs only. So that case, you must convert the analog information into digital information. So that is ADC. So different type of ADC is there. Yeah, right. So to convert the analog information to digital information. For suppose this main, so for suppose it is a analog type of input. That case you only use ADCs. For suppose your sensor gives the digital information, you directly connect it to the microcontroller. So there is no need to connect the ADC. Is it clear? Okay, no. And next one is controller or ASIC. So you just give the name to the block is the controller block. So in controller block, three different components is there. So microcontroller, microprocessor, and ASIC IC. So I think all already know the
So
microprocessor and the
people don't know
microcontroller,
how
right?
to extract the work.
Yes or no? So all I know the microcontrollers and the microprocessor. So one is the name is different, ASIC IC, right? Anyone know the ASIC IC full form of the ASIC? Anyone? So in the
Application
academic,
specific integrated
all
circuit.
of you know the microcontroller and microprocessor, right? Yeah, right. Good, good, guys. So Lalita is good. So ASIC means application specified IC. Application specified IC. So IC means integrated circuit. So any example? Any example for ASIC? IC? Guys, please respond. Any example for that? So XG1 is the microcontroller. Remember that point, okay? It is a microcontroller. IC triple five is good, good. IC triple five. So it is designed to a comparator, right? Mobile phone is not example for that. So there is a programmable device. Okay, there is no programmable device. So you already design some internal circuit. Based on that, we design another circuit based on your requirement, like comparator. Yeah, right. Operational amplifier is good, but operational amplifier is the analog component. Clear, guys? Browser also digital component. Right? Microprocessor is the digital one. Microprocessor, microcontroller, digital electronics. So it is a program device also. So SCI system, there is no program. So those type of no programmable device, okay. You just use the internal circuit to extend the operations, like comparators, right? Yes or no? To generate the square waves that related circuits. Yes or no? Right. And next one is memory. So must most important thing to store the current information. Yeah, right. Bullying gates also. Right. Bullying gates also, no problem. So memory. So you must store some information. You required to store the information like CC cameras. So CC cameras also embrace system, right? But some information store the memories. So you directly access your CC cameras, you directly watch the current situations. Okay, no problem. So you read the previous data. You monitor the previous data. That case, you must use the memory to store the data. So that is case, use the memory. And next one is the DAC. First of all, so you are operating the output component is unlock type of signals. Record unlock type of reverse must convert the reverse. A reverse conversion, that is DAC. DAC means digital analog converter. A last one is activator. A last one is activator. Is it clear, guys? So this is the structure of embedded system. Is it clear or not? The previous slide is the block diagram of embedded system. This slide is the structure of embedded systems. Any doubt? For suppose you need to design your internal timing, internal clock-based related systems. So skip the sensors and ADCs. So given the example for actuator is just output component. So it depends some input signal to activate the internal operations. Those type of components called actuators. So given the example, LEDs. Just a small example is LEDs. So what is the function of LED? Just glowing just glowing, right? Convert the light signal. Electrical, so let's say, but it required input is electrical signal, right? So those type of counts actuators. Why DAC use? For suppose you control the, I mean, you give an example for that. So based on your motorbike speed, vary the brightness of LED. So how much of speed is moving, right? In the RGB LED thing. So you vary the DAC signal based on the DAC, digital analog converter used to generate the analog signal to control the brightness of LED. Okay. First of all, I give the one more example for you. That is your mobile phone screen bright controlling based on the sunlight or real-time light, right? So in this case, must know the DAC signal. So required analog signal. So digital signal given the only two states, either true or false, either on off. But analog signal multiple variations is there. That's why you are using the DAC to create the analog signal from using digital signal. Is it clear? Pranay, is it clear or not? Right. Okay, thank you. And next one is components inside the embedded system. What are the components? So you feel to design some embedded system. So what are the required components? So based on the application, what are the required components? So first one is the required power supply. Every system must require a power supply, right? Yes or no? So we have how many type of power supplies your real time, guys? How many types of power supplies is there? Yeah. So what are those? M Kumar, Hemant Kumar, sorry. AC or DC, right? So So our digital electronics and digital systems require what type of supply? Suppose your user systems are your regular user systems or your design system required what type of supply? Yeah, you're talking about the electronics only, right? Yeah, right. So electronics compulsory DC. So, but your real-time input is what is the real-time supply to your home? What is the real-time supply to your home? Right, AC. So, a small question for to you: how to convert the AC to DC? How to convert the AC to DC? So, AC is alternate current to direct current. Anyone? So, most of them are given the transformers, inverters, rectifiers, using rectifiers. Okay, good, good, good. First of all, you must identify the magnitude. So that is the magnitude means voltage, right? So in power supply, 230 volts is a peak voltage, right? 230 is the peak voltage. But our requirement is more than 12 volts, I think. Below 12 volts or 24 volts, right? I said no. The AC signal maximum voltage is maximum. No, no, no. AC maximum voltage 240. Okay, it is fluctuated to 242, 230. Okay, fine. So we give them average value is 230 volts, right? That is the maximum amplitude, right? But a required maximum amplitude in we're talking about only simple home supply only, right? 230 kV, that is not possible to convert AC to DC. Again, we convert to the magnitude of the AC signal using transformers, right? But in our applications, we must convert the 230 volts to DC supply, right? So first thing is you directly use the transformers. Okay, must use the step down transformers. We have two type of transformers is there, two different types, right? So what are the types of transformers is there? Yeah, right. Step up and step down. So how to identify the difference between the both? How to identify the both different different type of transformers based on the turns. That means warning. Okay, good. Turns. So number of turns based, right? Yes or no? Yeah, right, right. Good, good. So first one is minimize the amplitude to reduce the amplitude of the signal. So you must use the transformer. So transformer input, what is the input of transformer? What is the input of transformer? AC. So output of the transformer? Output of the transformer. So both input and output of the transformer is AC only, right? Input of transformer is AC, output of the transformer is also AC. So next step is to convert the AC to DC. So next step is we go for the next step. What are the next component? What is the next component in this process? Here are diodes. So diodes is converted to the negative cycle to positive cycle and a single phase. So you phase conversion. Electrical circuit is a phase conversion. Okay. So in AC signal, positive phase is there and this phase is there, right? Two different phase. So negative phase is converted to the positive space, so you must use the rectifier circuit. Rectifier circuit means diodes, right? So diode output is the varying signal, but phase conversion only. So we give the rectifier input is alternate phases, alternate phase. So our rectifier output is converted to the rectifier output is single phase, any one of the single phase is a positive phase or negative phase. So the rectifier out, what is the output of the rectifier? Any type of rectifier circuit, output is no guys, it is not DC. That is a pulsate DC. So because pulsate means, so DC means it maintain the constant value. DC means it must maintain the constant value, right? It must maintain the constant value. But a rectifier activity, some ripples is there because the rectifier is converted to the phase conversion only. The rectifier converts the negative phase to positive phase conversion, right? So no. So the rectifier output is pulsating DC. So pulsating DC is converted to the DC. How to convert the pulsating DC to DC? Yes. So to remove the pulses, to remove the unwanted ripples, okay, unwanted gaps, you are using filters, right? You use the filters. So what is the working function of capacitor? How convert the capacitor to your circuit? A series or parallel? But suppose your capacitor connected to series, what happened? So for suppose your capacitor connected parallelly, what happened output? Why? Why convert the capacitor parallelly? So what is the work capacitor? So required output is DC, right? Required output is DC. So the capacitor connected in series or parallel. So more, what is the working of a capacitor, guys? What is the working of capacitor? Used to store the energy. When you store the energy, how to convert the capacitor to store the energy? Thinking yourself, answer the question. Okay. First thing, the chain charge and discharge, right? Okay, good. When so how to convert the capacitor to charge or discharge? I think okay, good. It store the energy. So that is the correct answer. So when how to convert the capacitor to store the energy? By giving the power. So here two different type of connections is there. Any component two ways connections, right? Is a series and parallel. So yes or no? So any other way to connect the any other component another other way? Guys, respond. Here any component connect two ways only. Human, right? Parallel or series? Yes or no? During the peak voltage, it store. Otherwise, no, guys. So only one thing is there. The capacity charge only AC signal. It allows the AC signals. What is the meaning of low? So observe the function, main function of the capacity is to charge and discharge. When you will charge, so it must give the some AC signal to charge the capacitor, right? So the capacitor connected in parallel to the rectifier circuit because so it will allow the DC signal. When you are connected the capacitor in series, it not allow the DC because of there is no continuous path because the capacitor responds only AC signal. So response means to store the signal, right? Yes or no? So the capacitor connected to the rectifier circuit. So in that case, it allow the DC
How much
when you
time taking
receive the
class?
AC signal, it will collect the AC and convert to the DC to remove the ripples using capacitor. I think all are understand this point. You must connect the capacitor parallel to the rectifier circuit. Is it clear or not? In that case, remove the ripples. So when you come some ripples, it collect the ripples of capacitor and convert it to DC. Yes or no? Yeah, right. Okay. So main function of capacitor is store the energy. Which type of energy? That is the AC signal. It allows the AC through the capacitor only, right? It's not allowed DC. But suppose your capacitor is connected to the series, suppose rectifier capacitor series to the rectifier circuit. In this case, allow the H signal only. The output is always varying. This is not allowed, right? Uh, so that is the wrong way, right? So now capacitor is connected to the parallel to the rectifier circuit. So in this parallel connection, in this case, it allow the DC because if it is a parallel circuit, right? It allow the DC, and so you collect the ripples, right? You collect the ripples is to charge the capacitor. So once it reaches the maximum charge, then automatically discharge, right? So it converts the AC to DC. To remove the ripples, you must use the filter circuit. In the filter circuit, you must use the capacitor. The capacitor is connected to the parallel to the rectifier circuit. Is it clear, guys? Is it clear or not?
Clear, sir.
Yeah, okay, thank you. And the second thing is required voltage. What are the required voltage? The digital electronics. For suppose you are using TTL logic, transistor logic, you must use the 9 or 12 volts, right? But in IC related circuits, you must use the 5 volts. Do you understand my main important point? So our requirement is DC 5 volts. Our requirement is DC 5 volts. The rectifier output is some given the random value 6 or 9 volts or 12 volts based on the transformer. So there is several type of transformers is there. So 6 volts, 9 volts are the output 9 volts transformers, 12 volts transformers, 24 also is there, 18 is also there, right? But our requirement is 5 volts. So how to convert the again DC to DC? For suppose assume our requirement is 5 volts, but the transfer output is our entire circuit. Circuit is gives the 9 volts up to 6 volts. So how to convert the 6 volts to 5 volts? Converters. So what is the converter? Zener diode. Okay, good. It's a variable thing. Input is a variable thing. Sometimes you are using different type of transformers, right? Yes or no? Sometimes market is available 6 volts transformer, sometimes 9 volts, sometimes 12 volts. Okay. So as in these cases, how to convert these multiple voltage to 5 volts? Anyone? Photodiode. Super. Wrong answer. The resistor is for suppose you are using resistor value, there is no changes. Okay. For suppose you change the input, the resistor is fixed. Drop also fixed, right? But output is changed based on the input. So resistors are not a suitable component for to maintain the constant voltage. So you observe that some maintain the constant voltage circuits. So most of them are using Zener diode with the help of resistors, right? Yeah, IC 7805. Super. So it is a voltage regulator, right? Voltage control oscillator. It is a wrong word. Voltage regulators. So what is the meaning of 7805? What is the meaning of 7805? Anyone know the meaning of 7805? Anyone? So it gives a constant output also good. Yeah, no. Okay. So 78. So totally it is a 4-digit number. First two numbers give the either positive or negative. So 78 is the positive voltage regulator. 7N is one more series is there. 7N series is there. So 7N is the negative voltage regulator. Remember this point. 7 is the positive voltage regulator. The 7 is the positive voltage regulator, and 7 is negative voltage regulator, and remaining two this is output voltage. Remaining two is output voltage of regulator. So 780 is the positive voltage regulator, 05 is the output voltage of regulator, right? So what is the maximum current of the 7805? Maximum current of the 7805. Because we all any components you use in the circuit, you must know required input. Suppose you just interface your LED. So what is the required thing, required input to the LED? You must know these points. Okay. So the output of the 7805, what is the current output current of? So most numbers give the 1 and 1 point of this 1 ampere only. 1 ampere or 1000 milliamperes. So 1 ampere, 1000 milliamperes both are same, right? Only guys, one but not that is not answer, correct answer. So 230 volts. So regulator is given 230 volts, right? Janavi. The regulator output is fixed voltage is 5 volts and the maximum current is 1 amp only. But suppose you require max current, I mean, required is more than 1 amp, you must go for the another component. So that is the buck converters. Nowadays, so most cases are available buck converters. So 3 amp, 2 amps, 5 amps, different type of buck converters is there. But suppose you are using the regulators, so the output of the regulator is 1 amp only. Okay. But suppose you design some systems using GSM module. So currently, current today is available 5 volts of GSM modules, but required current is 2 amps. That case you are not suitable for to switch these voltage regulators. That case you are using the buck converters. So buck converter is different type. Different ambience is there. Is it clear? Yeah, right. So this is a way to convert the power supply, required power supply. So AC to DC. And next one is the processor. So previous block is called the controller. Now this slide is called the processor. Both are same. Okay. It is a controller block. So in controller block, three different components there. Microprocessor, microcontroller, and IC. It is not programmable device, but it is a combination circuits is there to create some experiments. And next one is the third component is the memory to store the information. And next timers and counters. The fourth one is very important in the counter sections. Money counting machines and the population counting machines or a number of visits.
ATM machines.
These type of counting equipment is must use the timers and counters. And next one is communication protocol. First of all, so you are using develop the large systems, multiple components is there. So there is a limited pins to connect the I/O components. So that case we go for the protocols, right? That time we go for the protocols, communication protocols. So you need the communication ports. Next, output and input components. Output or input pins. Yeah, okay. And next one is the basic circuits. Suppose you need to collect the information and create the circuit, collect the information. Suppose we give an example for the last seventh one is just interface your push button to the microcontroller. So I have one more doubt. So push button is the digital one or analog one? Anyone? A push button is analog one or digital one? Right. So digital one, right? Oh, analog one. So how to identify? How to say that word? Analog one. It is a digital one. Here only two states, right? Based on the behavior, it is a digital one, but it not use the digital outputs, right? Yes, sir. Yes or no? Based on the behavior, it is digital one. Because of it is the open and close. Only two states is there. So that's why it is a digital one. You simply it's a digital one. But digital means it give the information in format of 0 and 1. Right? Button not give the 0 and button not give the 1. So 0, 1 means what is the meaning of 0 and 1? Guys?
Domain.
What is the meaning of 0 and 0 means on, 0 off means something. 0 means
Then.
no. So 0 means logic 0. 1 means logic 1. So logic 0 means it gives the voltage levels. Okay, it is a voltage levels. Is it clear? Yeah, right. Logic 1 is 3.5 volts to 5 volts. And logic 0, 0 to 1.5 volts. I think it is come from very VLSI, strong 1, strong 0 concepts. Right? Same way, logic 1 means 3.5 volts to 5 volts. Logic 0 means 0, 0 to 1.5 volts. It is a logical value representation. So button not gives us these type of information, right? So we need to add some circuits, to generate these values in the oldest format. So that time we require some circuits to give the generate the signals 0 and 1. So those type of circuits in application, right? So these are the major components in embedded systems. Guys. So any doubts, any component, please respond in chat box. Any doubt in these 7 components of embedded system? Any doubt? Any required thing?
Sir, seventh one explain on second, sir.
But suppose or button directly not give the digital information, right? It is a physical component, right? It is a passive component also. It has some resistance. So it is a passive component, right? So the passive component is converted to the digital one, digital information. So how to convert the digital information? Based on the behavior, we convert the either 1 or 0. So to generate the either 0 or logic 1 or logic 0, you must connect to some hardware circuit, some hardware component, some basic component, those type of circuits. Okay. And communication port means we talking with face to face, right? And through some internet protocol, right? So some guidelines to communicate, to transfer the data or communicate to the hardware device is the communication port. So we're talking about the communication protocols, so the communication port in further sections is there. So how to control the any other component using communication ports. Don't worry. So logic 1 is 3.5 volts to 5 volts and logic 0, logic something. Logic 0 means 0 volts to 0 volts. You must mention the point is 0 volts. So this is the voltage replacement. 0 means there is no value. There is nothing. Okay. So 0 volts means something current is flowing. Okay. 0 is different and 0 volts is different. Both are different. 0 volts. So 0 volts, you mentioned the 0 volts. Current flow is there. Just you mentioned the 0. There is no flow. There is no continuity. Memory is to store information. So you track the previous day or information of your home. Something you develop some system to track the previous days of data. You must need memories. Okay. So timers count is to count. Timers count means just a example to count the information with respect of the behavior of the system. So I give an example for that. You entered the mall randomly. Okay. Some people are entered some certain time delays, right? So those members, how many members are entered inside the mall? That information collected by timers are counted. So both are same. So timers means internal operation purpose. You are using the internal operation that is called the timers. For suppose you are using external purpose, use purpose, the counters. So any other doubts? Please respond.
Sir, go to next topic, sir.
Yeah, okay, thank you. So you give the example for embedded system. So you're talking about blocks and what are the components, everything is completed, right? So you're given the real-time example for embedded system, right? So your suggestion
Sir,
for the embedded system,
washing
right?
machines, ACs, ovens, microwave
Good, good.
ovens, washing machine, ACs.
Super, Nana. Same answer is fine. But you can suggestion on the example. So I think all I know this. What is this?
Window AC, sir.
Yeah, right. Window. It is the
AC.
olden days of OC, right? Nowadays, so these very rare cases are observed, right? So most of us use advanced ACs. So right now, so observe these AC. What are the input components? What are the output components? How to give the instruction to the DC AC? Anyone? First one is what are the input components here?
Hot air.
What are these input? Anyone, guys? Supply. So supply it is not input component. Is without supply,
Sir, water, sir,
your
water.
device not working. It is must and should require thing of supply. Yeah, right, guys. So Nagraj is there. Nagumaland, I think name is I don't know. So first one is the push buttons. Here observe the push buttons is there. White color so some buttons is there. So input components are push buttons. And next one is the output. What is the output component here, guys? What is the output component? So every embedded system basic thing is the main one is the middle one is the controller and the input main block and output is the main block. So enter your AC system. That is the output component. So actuator is there. What is the name of actuator? What is the name of actuator?
Filters.
Filters. You observe the filters is the AC, right? So based on image, what are the input component? What are the output component? Give me a minute, guys.
Sir, input is push buttons, output is the fan, sir. Fan in the AC.
Output is cool air, sir. Coming cool air.
Repeat 1 second, guys. Yeah, what is the input? Hot air is the input, right? Cool air
Push
is the
button is
output.
there.
No?
Output cool
Hot air
air,
is
sir.
the input and cool air is the output, right?
No, sir. Push button is input, sir.
Yeah, right. Push buttons is the input. And next one is the output. One thing is there. Only one output component is there. That is a display. So actuator is inside the AC. That is a motor controlling unit. Actuator. Okay. Generate the cool air inside the AC. That is the actuator. Is it clear, guys? Right. Also here the mesh. Yeah, inside the some temperature sensor is there. That is also one of the input component. So display is the output component and push buttons is the input components. So what are the input and output components? Your picture. So these are only two things. Is it clear, guys? What is the controller? Consensus what? And next thing is, so in the blocks of inside the AC, how to control the AC. I mean, AC means air conditioner, right? Then the air condition, we change and activate the internal fan, right? So fan is the activator to collect the information of the room temperature. To collect the room temperature, that is the temperature sensor. to set your controlling level. So temperature, what are the reference temperature by using push buttons. To display the information, what is the current information of room temperature? That the current information is room temperature, right? So that information display on the display. So that is the output component. So push button internal temperature sensor is the input component. And next one is the display is the output component. Internal fan is the activator. So these are the blocks inside the golden disk AC. So sensor is the input component only. To calculate the room temperature, right? Guys, to calculate the room temperature, you must use the temperature sensor. So that is the input component. Every sensor is the input component. There is no other chance to change the position of the sensor. You call the sensor, it is the input component. You call the activator, that is the output component. Is it clear? Is it clear or not? Yeah, thank you. So next, how the function of the AC. First one, you observe the first one. Blocks, what are the blocks inside the, we give an example of AC. So what are the blocks of the AC? These are the
Cloud.
blocks. So first one is so it is cloud, right? So you given the cloud for the reference for the external environment. That's why you given the this cloud. So it is a representation of temperature, room temperature also. That's why you given the cloud. So first, the collect the external environment of temperature. Example, room temperature. We collect the room temperature, and the temperature is given to the ASIC IC. So here I'm using the ASIC IC for use of comparator. I think all are know the comparator, right? It gives the two reference values. Based on the two values, it gives the output is true or false only. Based on that, you activate the actuator. So first you collect the information of room temperature. You're using temperature, sir. Here, two different type of temperature is there. Allowed temperature and digital temperature. Two different type. Any type of sensor, the sensor collected through collect the information using sensor that information due to the ASIC IC. It is one of the input. Next, you also given the some reference input, right? You set the some room temperature 24 to 18 low, right? These levels. You set the any certain temperature level. So that is the second input. So based on the two inputs, the ASIC IC gives some information, either true or false. Okay, based on the input values, it gives the true or false values. Those values is given to the activator. Okay, when you will activate, when you will deactivate the function, internal function of the activator, based on the ASIC information. So these are the blocks of given example for the AC. Given example of AC. Is it clear, guys? How to working inside the olden days of AC. Nowadays of AC using different functions is there, right? Air direction, so temperature levels, temperature different ways, or hot air or cool, right? Say yes or no? Say yes or no, guys?
Yes, sir.
So advanced technology is there nowadays. It is the olden days. So that's why limited blocks is there. There is no programmable device. So it depends on the ASIC IC. So this is the example for blocks of AC. So today's session is over. Up to now, here any doubts, please raise. First,